so the first three you had two answers. So if you have something like these on the test, you'll have 2 points on each of those three because you were asked to write the equation of the line and then interpret that. So you have to tell a little bit about what it means. These three are nice because if we're writing an equation of a line, we're writing them in mx plus b. B is where it crosses the y-axis. You can look at the graph and get that on all three of them. You can look at that graph and see where it hits this y-axis over here to get your b. Then your m, you've got a couple options. You can either count rise over run, or you can use your slope formula. y2 minus y1 over x2 minus x1. Everybody remember those? Okay, so when I did number 1, I just subtracted my y's. So I did 1300 minus 800. And then I subtracted my x's, so I did 10 minus 20. And that reduced to negative 50. Everybody okay on that? So there's my m. The b, I saw a couple people write a couple different things because it didn't exactly hit on one. Some people used 1900, some used 1800. I wouldn't count you wrong for an estimate on that, but I used 1800, but I wouldn't mark you wrong. So we would have negative 50x plus 1800. If you use 1900, that's fine somewhere because it didn't make it quite to 2000. Right, you see that? So that'd be 1 point for number 1. Number 2 says interpret it. That just means put it in context with the actual graph. The graph says that's the balance on a loan and the payments. So if my X is my number of payments, this means that I'm paying $50 a month. My loan balance is going down $50 every month. So I put decreases $50 a month. That's what I put. There's more than one way to word that, but that's the way I worded it. Okay? Make sure you do both of those. Don't get a good answer on the equation and then miss points on the interpreting. Trevor, you all right over there?
I'm looking for a pen. I'm sorry.
That's okay. I want to make sure you're all right. Find one?
He wrote in pen and he's trying to erase it with the pencil.
So I can mark through it. No, it doesn't go through pen.
No, still.
Latest statement I've heard in a while.
Where?
Right there. Does that look like it went through?
Thanks teamwork, doesn't it?
Photograph.
There's the buzz.
There.
No, that doesn't work.
Alright, number 2. Same deal on number 2. I found the slope. I subtracted the y's, 45 minus 30. Then I subtracted the x's, 5 minus 2. So that has a slope of 5 on number 2. You ought to be able, there's no guessing on this one, you ought to be able to look at it and see that its b is at exactly 20. So your equation would be y equals 5x plus 20. That'd be one of your answers. Your other answer now is to interpret what that means, and you got to look at the graph and see that we're renting a canoe for hours on the x-axis, and our total cost is y on the y-axis. So I'm multiplying 5 times the number of hours, so that would mean that the canoe rents for $5 per hour.
We gotta write that?
It said to write the equation and interpret it.
Wait, what?
Yeah, what did we interpret on number 1?
Our loan decreases $50 a month. So we were searching for a pen over there.
I'm sorry.
Did you subtract the 45 by 30 to get 15?
Yes, ma'am.
Oh, okay. I was trying to figure out where the 15 came from.
You got it.
Where's the whole thing?
Where the graph hits the y-axis over here, that was on 20. Good. Well, that's good. You got to know that. That's a good question. All right, we ready? We got to keep going. Number 3 is the easiest one on here, but we didn't never do a horizontal line in class, and so that confused some people. But it's really the easiest one. Everybody got what you need here? Got it. Yes. All right. So when we have a horizontal line, such as on number 3, a horizontal line has a slope of 0. Always a slope of 0 on number 3. So if we plug that in, 0 times x, there's nothing there. So all you're going to have in your equation is the b. You get your B by right here where it hits the y-axis, and on that graph, that goes up to 6. So y equals 6 is the equation on that, Trevor.
Would you count it wrong if we did put y equals 0x?
No, not. That is correct, so that's good. Now, along these same lines, while we're talking about it real fast, what's the slope if the line is just straight up vertical? That's when you can't say 0 because it does rise. You have to actually say it has no slope.
Yeah.
Okay, remember that's an old Algebra 1 thing there. Alright, so we've got our equation on number 3. Then we got to interpret that. Well, this is an easy one to interpret. What would the treadmill be set on in this thing? Look at that graph. What's the treadmill set on?
6 miles an hour.
Good, 6 miles an hour. So you could say something, the treadmill's constant 6 miles an hour, treadmill's set on 6 miles per hour. I wrote the treadmill speed is set to 6 miles per hour.
Is B 6?
Yes.
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 Where did you get 6?
That's
Well,
right
that's
here
the
where
law.
it hits the y-axis.
Oh.
Right.
Alright. 4 through 7 now is the most recent thing we did with the systems of equations. These four, all 4 of these had a place where it didn't give you a blue light special, but it was a good deal. You had a place where you could shorten some work in all 4 of them. Okay, we ready? Alright, so on number 1, I'm not going to write all 3, or 4, excuse me. I'm not going to write all 3 of the equations down there. I'm just going to write what I did to start. I put the first 2 together, so I've got an x plus y plus 3z is equal to negative 4, and then a negative x minus y minus 2z is equal to 5. Reason I chose these 2 is because I can tell that I can add and I can get rid of 2 variables here. X plus negative x is nothing, he gone. Y plus negative y is nothing, he gone. 3z plus negative 2z is 1z. Negative 4 plus 5 is 1. So we already know our z. Okay? Now, look at your third equation. Here's where some people saw it and did it, and some people made their life a little harder here. You could go ahead and put 2 more equations together to try to eliminate something, but your third equation only has 2 variables. So we can plug that z we got into that third one. Okay, so I'm going to say 2x minus 1, because my z is 1, is equal to negative 3. So we would add that 1. 2x is negative 2.
He gone.
So he gone. X is negative 1. Everybody okay so far on that? Now we got to take our x and our z back to one of our original ones to find our y. I chose the first one, so just looking at how I worked it this morning. So I had x plus y plus 3z, and z's 1, so 3 times 1 stays 3, is equal to negative 4. This negative 1 and 3 gets me 2. So I got a negative 6 for my y. So we had x, y, z.
That's number 4.
Uh-huh.
Doing that.
Wait, we just write the x, y, z on here?
Uh-huh.
On number 4.
Alright, so we're ready for 5? Okay, good. I needed a coffee sweet. Thank you. Alright, you got a Molly P? Sure.
I'm just wondering which page you was at.
The first one.
There wasn't there like 3 in there?
It was 3z, and my z was 1, so 3 times 1.
Oh.
I didn't write that, I'm sorry. Alright, number 5. I put the second 2 together first.
Second?
No,
The second one, the third
the
one?
second one, the third one, yeah.
That's what I did.
Okay, so I'm gonna add those, let me get those 2 written. And 2x plus y plus 2z is equal to 3. And then 2x plus y plus 3z is equal to 8. Now you could on this be getting rid of either the x's or the y's.
Where are the X's?
I did the x's good, Landon and Chloe. I added this. That's nothing.
He gone.
You go 2y. I love it, Landon. 5z and 11. Okay.
The first one.
The first one with the second one now is what I did next. That's what Trevor did. So I'm going to have to double the first one. So I'm just looking at my paper there. Multiplying it all by 2 would be 2x minus 6y minus 2z is equal to negative 18.
Wait, what?
I just multiplied the first equation by 2. Now I'm going to put it with the second one.
Eliminate the z's.
No, you got to eliminate the
Oh.
x's again. Whatever you eliminated the first time, you got to do the second time.
You're in trouble.
But that's good here because it does get you a 2 for 1 on that, Landon. That's what you were seeing. The z's do go away also. 2x, negative 2x, nothing. He gone. Negative 6y and y's, negative 5y. And here's what Landon was talking about. Negative 2z and 2z's also. He gone. Negative 18 and 3, bless you, is negative 15. So now we know our y. Take that y over here to our first new one and plug it in and you'll get your z. So 2 times 3 plus 5z is 11. 6. 2-step middle school equation. And then divide by 5. So you got your z. Now we need an x. I'm looking to see where I think I plugged it in. I don't know. Can't tell all my
This is the
screws.
first one.
Okay, I'm doing the first one with Stephen. I'll have x minus 3 times y minus z is equal to negative 9. So that's negative 3 times 3 is negative 9. Negative 9 minus 1 is negative 10. Add your, I got this extra equal sign in there. I kept doing that yesterday when we put extra equal sign. Add your 10, and x is 1. X, Y, Z. 131. It's my least favorite defense in basketball.
Will the x and the z always be either negative 1 and 1?
No, we just had a coincidence on a lot of problems so far. Could be anything.
You gonna like the 131? I think it's fun. Too many gaps in the 131 for me. Alright, 6 and 7 were some weirdies. Did y'all get your weirdy answers for 6 and 7, anybody?
No, I didn't get it.
Good, Stephen. I already jumped ship. Alright, everybody got what you need here? Got your carry them.
You can get rid of the 2 for 1.
Layden, thinking I did. Alright. Let's see, Layden, I did 1 and 2, is that what you said?
Yeah, let's do that.
That's what I'm doing.
Alright. So I got x plus y plus z is 7. And then I've got x minus y plus 2z is 7. Alright, so my choices here, I've got my x's ready and I got my y's ready. So I got to decide which one of them I want to get rid of. Since my third equation doesn't have a y, I'm going to get rid of the y.
Yep.
Since the third one doesn't have one. So I'm going to add here. X and x gets me 2x. Y and negative y is nothing. He gone. Z and 2z is 3z. 7 and 7 is 14. Okay. Now I don't have to get another new equation because my third one is already missing a y too. So I can go ahead and put those together. So I've got this new one. I'm putting it with my third one. My third one happens to say 2x plus 3z equals 14. Flashing neon sign ought to be telling you something right now. What?
Something wrong.
How much you say that?
You gotta multiply.
Infinite solution.
Good. Why does Stephen know this is infinite solutions?
Because they're all the same.
They're exactly the same. Very good. When it's the same line, there are infinite many solutions. Okay? No, there's a sign for infinity, but it's like the sideways 8.
Can we do that?
No, because that's not infinite solutions. If you get there and you think you still want to put them together, the same sign, so you'd subtract. 2x minus 2x is nothing, he gone. 3z minus 3z is nothing, he gone. So you got 0 equals 14 minus 14, 0. Remember we said if it's a true statement, it's always infinite. Good, we'll remember that. Alright, 7's another weirdie, but it was a weird way that I got the answer.
1 and 3.
1 and 3?
Yep, 1 and 3. You can delete all of them.
Alright, 1 and 3. So I've got negative x minus y minus 2z equals 9. Negative x minus y plus z equals negative 10. Alright.
Yes,
That's right. Subtract. Negative x minus negative x is nothing, he gone. Negative y minus negative y, nothing, he gone. Negative 2z minus 1z is negative 3z. And 9 minus negative 10,
no,
19. Okay, we got here and we started whining and panicking about decimals. And I get that because this one is a fraction. I'm just going to leave mine in a fraction. If I divide that by negative 3, I'm just going to leave it at negative 19 thirds. Okay, it is repeating decimal, but I'm going to leave it right there. Okay,
While we're
Trevor.
talking about fractions, can you show me how to put a fraction in this?
I think
Yes.
I know how to do that.
Are you sure you don't?
Yeah, I know how.
Alpha, y equals, and then enter.
There.
Oh, yeah. Alpha y is
I told you that.
Alright, which two do you want to do now?
I wanna.
Now we have Z. So,
Yeah, but we don't have anywhere that's only got one to plug that into, so we've got to get another new one without a z. We need to get rid of z's.
Do the second, third one.
Second, third one will be ready. I like that, Chloe. So that gets me negative 2x minus 2y minus z is equal to 1. Negative x minus y plus z is equal to negative 10.
wait, what are we
Chloe, we don't want to do that, sweetie. My bad. Because this is going to get rid of the z's, and I've got a z I need to
Yeah.
plug in.
Okay.
My bad. So let's pick something besides the second and the third one.
1 and 2.
First
Okay.
and second.
Yep, that'll be a good idea. That was my bad. 1 and 2, they've like got a waxer going up and down. On 1 and 2, I'm going to have to multiply 1 by what?
2.
2. So I'm going to double everything in the first one. So it's going to make it a negative 2x, a negative 2y, a negative 4z, and an 18. And then my second one stays the same. Alright, so I'm adding here. Nope, subtracting again. Alright, Trevor.
Yeah.
Negative 2 minus negative 2 is nothing, he gone. Negative 2 minus negative 2 is nothing, he gone. Negative 4 minus negative 1 is negative 3z. And 18 minus 1 is 17. That 18 should be a negative, shouldn't it? Negative 18 minus 1.
Wait, wow.
What would have been a negative? Hang on.
I'm looking at number 5. My bad. Number 7 is positive. I looked up at number 5.
I've been doing that all day too.
18 minus
Divide by.
1 is 17. Okay, this is why I know something is weird on this, because I've got to divide by that same negative 3 again. Look, compare this to this. Negative 3z is the same, but they're not equal to the same thing. If we go ahead here and divide by negative 3, that gets us z is negative 17 thirds. Is it possible to have z be two different answers?
No.
No, z's got to be the same
So
thing
no
every time.
solution.
So that's what tells us that that one's a no solution. Hit math. You got to have it on the calculator. So go ahead and do 17 divided by 3 and have that on the calculator. And then hit math, enter, enter.
I used to have them.
Alright, 8, 9, 10. Now, after you had those 4 long ones, 8, 9, 10 are short and sweet. So let's look at 8, 9, 10. They tell you to match the transformation with the graph. Match the transformation with the graph and then write the rule. Okay, so on number 8, what I noticed on number 8, it says g of x equals negative f of x plus 3. Plus 3. Okay, first off, let me make you a little side note. All of those are linear, and the parent function for a line looks like that. So for this one, for number 8, I've got to take that line and I've got to scoot it up 3. So it's got to be going through that point. Which of those choices has a point that goes through 3 up there? C. So number 8 would be C. That'd be your first answer. Now it wants us to write the rule. And this is easy. All you have to do to write the rule is take out that f of x. So you're going to say g of x equals negative x plus 3. You just make it look normal instead of having an f of x in there. Now, how come on C the line comes like this? Why is it going a different way? Because that negative flipped it. Very good, Chloe.
Let's see.
C, it was multiple choice on number 8. C, 8 goes with choice C.
Oh. I get what you're saying.
Which means A has to be non, right? Because it's a negative 1.
No?
Oh,
I
wait.
get that.
Oh, wait, there's a negative 3 in the other one.
Alright, 9. On 9. Let's look there. Chloe's on 9. It's got 3 times f of x minus 1. So it's got to take this original parent graph. Let me go back to my original one here. It's got to take that original parent graph and it has to scoot it down 1. So instead of crossing the axis at the origin, it's got to cross it down 1. So which one of those hits it at down 1?
B.
So good. So number 9 will be B. And then all we got to do to write our function is put it with g of x and take out that f of x, just leave an x. 3x minus 1. Okay, so that leaves 10 has to be A, and that should make sense to you because it ends in a plus 1. And A is scooted up just a little bit past the origin, right?
So that should be g of x equals negative 3 plus 1.
Negative 3x. So 10 will be A, g of x equals negative 3x plus 1.
Yeah, I'm kind of like that.
A lot of people got confused because they had those f of x's in there, but you're just taking the f out. You know, it's not very hard on that. All right, I liked 11. 11, we're going to write a system of equations like on numbers 4 through 7. We're going to have x, y, z's in there and solve them. And I liked it because I like baseball and it was interesting to me. figuring out how many tickets we bought. Let me tell you this, that you could get it using trial and error. I know that. You could get number 11 right using trial and error, and I don't mind that. But I'm going to do the systems of equations like we would do, like we learned in class. Okay? All right, first thing it tells me here, we got 3 choices for our tickets. We can buy reserved tickets, we can buy field level tickets, or we can buy box seats. I named this my X, my Y, my Z. Okay? Then it tells me how much each of them cost. I'll get to that in a second. It tells me I bought 10 total tickets. So however many reserved I bought, plus however many field level I bought, plus however many box seats I bought, total to 10. Okay? Then it told me how much my total bill was. So I've got to now put those prices in on the mix. The reserved seats were $20, so $20 times how many I got. The field tickets were $50, so 50 times how many of those I got. And these rich box seats are $100, so 100 times how many of those I got. And my total bill was $370. Okay, but we need 3 equations when we do this, right? They gave me one last little bit of information. It says I have twice as many reserved tickets as I do field level tickets. So that means I'm going to have twice as many, so 2y would equal x. Okay, so there's my system of equations to solve. So I'm looking at just like we did on 4, 5, and 6, and 7. What I would do, though, to decide what to eliminate, since this last one doesn't have a z, I would put the first 2 together to eliminate a z. Okay, so what would I have to multiply equation number 1 by to eliminate a z? 100, because we got 100z there. But that's easy. 100 times x plus 100 times y plus 100 times z is equal to 10 times 100. I added one too many zeros. You're right, Stephen. Alright, then I've already got 20x, 50y, 100z, forgot a 1 in front of 370. Alright, we're getting rid of those z's, so am I adding or subtracting?
Subtract.
Good. Gets me 80x plus 50y. 100z minus 100z, Landon?
0 or 200.
I wanted to, he gone.
Oh, he gone.
630. Alright, so now I can do a couple of different things to this. Because remember that third equation also doesn't have a z. I can rewrite this, like make it be x minus 2y equals 0, and then multiply it by something. But since this is what x is, I'm going to use some substitution here. X is the same as 2y, right? Isn't that what that means? So I can put 2y in here for the x. Substitute that in. So I'm going to say 80, and instead of x, x is the same as 2y. Okay, 80 times 2 is 160, so you got 160y plus
That's right.
50y. Yes, ma'am?
Can I see Jody February, please?
Okay.
Thank you.
When we add on that, combine the like terms, that's 210y.
630 divided by 10.
Trevor's on it.
Got 3.
Now we can now figure out how many of all the different tickets we bought. I still got people catching up on that. Let me give you a second.
Couldn't we find out what that? Never mind.
And you can real easy now figure out your X. I'm going to give everybody a chance to get caught up. Alright, so Y was our field level tickets, so we bought 3 of these. Now, to get X, all we have to do is multiply that by 2, right? X equals 2 times Y, so X would equal 2 times 3, so X equals 6, so we bought 6 reserved seats. How many total tickets did we buy?
10, we got one.
So we only got one of the fancy ones, so somebody's sitting all by themselves in the fancy seat. That'd be me. We don't want none, Jody. Alright, we get that one ready, flip that page over.
Yeah, glasses will fall off. You have to really kind of
I think you and Kaylee Sutherland are having a contest for who gets hit in the face the most.
Alyssa Root got hit in the face a lot last year.
Alright, we ready? Slow it down there. The Y was 3, the X was 6, and the Z was 1. Okay, on the back, 12, 13, and 14 don't take you very long to get. Says on the directions, graph the function and its parent function. Okay, so on number 12, the parent function, it says g of f of x equals 2x squared, so the parent function would just be 1x squared. And we've got that in our notes a million times. It's a parabola through the point 0, 0, 1, 1, and negative 1, 1. Okay, there's the parent function. That's one of your answers. You got a lot of answers on these three. Then it says to graph the function they gave you, which was 2x squared. G of x or f of x or whatever, I'm just going to put y. If you do that, now if I use my normal little points there, if I plug a 0 in, 0 squared 0 times 2 0, so I still have that point at 0, 0, but now these are fixing to change. 1 squared 1 times 2 is 2, so where this was over 1 and up 1, now it's over 1 and up 2. Same thing here, negative 1 squared is 1 times 2 is 2. So where this was left 1 and up 1, now it's left 1 and up 2. So there would be our other parabola. So there's 2 points so far. We got both of those parabolas graphed. Point number 3, it says describe the transformation. What's different between these two equations that I have written?
We got a 2 right
The
there.
2 out in front, which means a vertical stretch of 2.
Is that what we write?
So you got to have 2 graphs, and then you got a vertical stretch of 2. So there's 3 points on all 3 of these.
Is this going to be on YouTube?
I've got it recorded.
Alright, I might have to rewatch it.
Are we okay? 13? 13, what family would the graph on 13 belong to? Linear, very good. So the parent function goes through the origin with a slope of 1. It's supposed to be through the origin. With a slope of 1. So there's my parent function, just y equals x. Now I have to graph that function they gave me. Okay, I could make an input-output table if I wanted to, or I could use slope-intercept form. It has a y of 6, so I go up 6, and then it has a slope of negative 1, so I'm going to go down 1 and right 1. So the new line would look something like that. That'd be my new line. It was y equals negative x plus 6.
How'd you know to go down 1 and right 1?
Because the slope was negative, so it's always down 1, right 1, always on a negative slope.
But if it's positive, you go up,
Up 1,
1.
right 1.
How would you go left?
You could go left if you go...
I just threw you off.
No, that's a good question. If your slope is negative,
Yeah.
so we got a negative 1x. To do a negative, your rise over run could be a positive negative, or it could be a negative positive. So to get to go left here, you would then have to go up.
So it's pretty much the opposite.
Yes. Okay, then to describe the transformation, it's got plus 6 stuck on the end. So it went vertical slide. This is how I wrote it. Vertical of 6 up. And then it's got a negative stuck out in front. So that's a reflection, not a rex, a reflection on the x-axis. That's what I was trying to write when I wrote a Rex. All right, 14, when you get ready. We've got an absolute value graph. So I know the parent function, and we've got these in our notes. So v through the origin, and both of those go through the point 1, 1 and negative 1, 1. Now I'm supposed to take that, that's just the absolute value of x. Now I'm supposed to take that and make it negative 3 absolute value of x. So that means that point at 0, 0 is still going to be there, because the absolute value is 0, 0 times negative 3 is 0. But that point at 1, if I plug a 1 in, absolute value of 1 is 1, times negative 3 is negative 3. So I would go right 1 and down 3. If I plug a negative 1 in, absolute value of negative 1 is 1, times negative 3 is negative 3. So I would go left 1 and down 3. So my new graph would look like that.
Since we already
Should
know,
look skinnier. Go ahead, Trevor.
since we like already know like the absolute value or whatever, it's going to be a v.
Just draw that on there. So to write how this changed,
Reflection.
it's a reflection on the x-axis, and I can't spell, just save my life. A-X-I-S. Say that again, Stephen. Oh, I thought somebody was whispering it up there. Wasn't you?
Well, I did, but I said it was correct.
Oh, it is. No, it is. A vertical stretch of 3. The negative got us the reflection. The 3 got us a vertical stretch.
Booyah. Is this how big is our test going to be this big?
Mhm.
You have a test in here tomorrow?
Yes.
That's why we're doing the review. This look, our test is just like
Oh,
this.
God.
She just mixes it up. And don't try to cheat either because it's a different test. I
That's
promise.
an L. That's an L.
Ain't that different test. You mix them up.
This is
Trevor took an Algebra 3 test last period.
No, I didn't fail. I don't fail.
That's right. No,
He
you
just
don't
gets
know.
us very low.
That's why you go here now, Trevor?
Alright, 15, I didn't do any fancy equations on. It says the table shows the height of the football over time after it's been kicked in the air. What we know about a ball being kicked or thrown in the air is that it makes a parabola. Okay, it goes up for a while, then it levels, then it comes down for a while. So they gave you that table there, and look at that. You see at 0 seconds, it was at 3 feet. So they teed it up 3 feet off the ground, I guess. Then 152, 287, 3, 108, 4, 115, but then 5, 108. So at 5, it started coming back down, right? See that? How 115's in the middle, and then you got 5, 108. So if you were at 4, 115, and then we start coming back down, 5, 108, what would 6 be? Look at the table. 87. So 7 would be 52. So 8 would be 3. So there's your answer. After 8 seconds, the ball would be just about to hit the ground.
What number are you
That was 15. Now, it had another question that says, what type of function is that? What type of function makes a U-graph? Yeah, but what's the function called? That's right. Quadratic.
Quadratic. I hope I get the test just like this one.
Oh, yeah.
How'd you figure out that? It was quadratic.
Because it's parabola. Yeah.
All right, 16, 17 are pretty simple. That's like what we've done on the bell ringer the last couple of days. 16 says write a function that represents us taking that one that's already there and reflecting it in the y-axis. So we've got f of x. Thought I hit a new page 7 times. F of x is -2 times absolute value of x minus 1. When we reflected the y-axis, it was weird. We made a note about it. There was a shortcut so that we didn't have to go through distributes and everything. Reflection in the x-axis just gets stuck out in front. But the shortcut that we noted when we reflected in the y-axis was all you had to do was change the sign in the bars.
Oh, that's our shortcut, so that's the answer?
That's your answer for number 16.
So absolute value, to find the reflection, you just change the sign
If it's a reflection on the y-axis.
on the Y.
Is that a 1?
Yes, I forgot a 1. I got a 1 and a bar there. There we go. Alright, 17 scooting 2 up just adds 2 on the end. So it was 2x plus 5. So if we add 2 on the end, our new
It'd be 7.
equation is 2x plus 7. Good job.
You're pretty smart.
Alright, 18. 18 says we're going to do a vertical stretch by 3 and scoot it up 2. Okay, so they give you f of x equals x squared. We're making g of x equals vertical stretch by 3. We multiply it by 3 and scoot it up 2. We add 2 on the end. So that's all you have to do for 18. We got 3 answers for 19 on the last one, so get ready for that one. Alright, I'm going to go ahead on 19 and write that function while you're getting there. F of t, they used t, no biggie, negative 7t squared plus 70t plus 3. Alright, it says your friend is watching as you hit the golf ball. There's the flight of the golf ball. So again, doesn't really matter a whole lot here, but the golf ball would be a parabola, it'd be a quadratic. There's the equation that they came up with as the ball's going through the air, but after hitting your shot, the friend claims that if you strike the ball half as hard, your shot will be more precise. So they're trying to get you to back off on your swing a little bit. Write a new equation that would represent that. So if I strike the ball half as hard by 1/2, I'm just going to take this, Stephen, T, it's on your paper. I'm going to take this and multiply it by 1/2. So I'm going to have g of t.
I don't like the T because it kind of looks like a
Yeah, that's why I tried to do a cursive one, but then y'all can't tell that.
What is that thing?
It's a T.
It's on your paper. Now I'm going to distribute 1/2 to all of these. Okay, you can put them as fractions or decimals, either one. That's going to be negative 7/2 t
X equals 3x
plus 35t plus 3/2 t. If you put them as decimals, that's okay, or put that like as a mixed number, that's okay. But that's what you would get after you distribute 1/2 to it. So that's your answer number 1. That's your new equation. We distributed 1/2 to everything. Okay. Then it says how high will find your new equation and describe how it changes. So what did we do to that? I skipped a step to just give all those 1/2. That would have been like I had 1/2 stuck out here in front, wouldn't it? So something stuck out in front means a vertical shrink or stretch. And since that's smaller than 1, that would be a vertical shrink of 1/2. So I've got 2 answers, 1 and 2. The third answer says, how high will the ball be after 6 seconds? So I'm just going to throw the 6 in for my t. Negative 7/2, this is supposed to be a squared, times 6 squared plus 35 times 6 plus 3/2. That last one's not supposed to have a t. Y'all got me frustrated with t's and I started putting them everywhere.
I don't know. Oops, I didn't say that.
Alright, so work that out on your calculator and it ends up being 85.5 feet. But work it out, make sure you can get it and check that.
Wait.
I just plugged 6 in for all the t's.
The first thing for the TNT.
Yes, so we had a 1, a 2, and a 3 on that. Have that study guide with you tomorrow. I'll let you use that and any notes you got.
You let us use this?
Yes, any
Oh,
notes.
it's going down tomorrow.
Any notes.
Yep.
Yes.
Hey, any notes we have?
Yes.
Even our phone?
Nope, not anything electronic.
Let me use Mathway.
Not anything electronic.
Let me use photo.
Dude,
No.
yes,